So smart percents or percent references is a new feature that we added in 14.1, and it's a spin on percent or referring to the previous evaluation. And so I'm just, instead of actually talking about all the stuff that I'm going to do, I'm just going to introduce it via examples and just go with it from motivation through to the usage and then through to some of the internal mechanisms of how they work. Okay. To talk about smart percents, let's talk about original percents, just a normal percent. So if we do some computation, we can refer to the previous value by just percent. And if we evaluate that, it gives us the previous value. If we have some other particular computation, we refer to that percent now will give us the last evaluation. Of course, we have two evaluations here. We can go percent, for instance, and that will give us the second last value. Or we could refer to percent 5 will give us the out 5, and percent 6 will give us the out of 6. And just if you haven't ever realized, if you hold percent and actually take a look at its full form, percent is actually just a short form for out. And of course, if we have some particular value here, percent 5 is just a short form for out 5. Okay. So where do smart percents come into this? Well, let's motivate this with an example. Let's consider something, we do some kind of calculation here. We solve x squared equals 4x minus 4, for instance. And let's get the solution in x. And then let's turn around and get the last value of that. Okay, so we've got some result of some computation. We want to do something that depends on that previous result. Let's just do some simple plot. X goes from 0 to the last result. Okay, so that seems to work. Now, that's not exactly the plot we want. I've decided I actually want sine of x. And I try and do that now, and it doesn't work because, of course, percent here in this calculation is referring to the previous result, percent 16, or in and out 16, which was the result of the plot. So I have to evaluate this, the computation again, and then evaluate that. And so that works. And so then if, again, if I do +1, of course, it doesn't work again. So I have to keep evaluating the things it's referenced to actually make it work. And so this simple solution is that I'm going to be smart about this. I'm going to turn around and put in an actual value, so percent 21. And now I can change this as I want and put in some different values, and it's working, and that's grand. But now, of course, if I go here and say, well, that's not exactly what I wanted. I wanted that computation here, and now I try and do this, and now it's getting percent 21 instead of percent 26, and I need to change things. So each time I've either got to evaluate this before and keep this a non-numbered percent, or if I number it, then I have to actually keep updating the number once I evaluate the inputs. So this isn't great. So that's the motivation. I mean, it's not terrible, and we've done it this way for many years. And of course, one solution about this is putting in an actual variable. Answer equals something like that, and you go to answer. But then, of course, you have to name everything. And so this now works as one would think, and you can go here and do it. And so this is really having an unnamed variable. But let's say we want to just want to work, and so work in the same way as we did before. Percents were useful, and then have them be smart. So that's what we're going to do. So what's a smart percent? So if we have some particular value here, and you've seen this menu now come up, and it's as we can cursor through this, we sort of see these different values, and so now if we choose this percent and we just hit return here, we get percent 37. And it evaluates sort of like a percent. It's labeled, and so it works. We can get it, we can copy it, we can evaluate it down here, plus t, for instance. It's doing what it should, get some particular other value, create a percent reference to that. I could get those in a particular cell, add those together, and things will just work. We can copy these. As we cursor over them, we see the actual reference to. There's a menu. I'm going to go through these options in a second, and a little bit more extensive look at the percent references. But with this, one of the interesting things, this cell refers to this in and out. And so now if I actually update the cell here and change this to 1 plus, W here, and I evaluate this percent 37 will change. This is no longer going to be around. And these references down here will actually update live. If I evaluate this, and voila, we see that's percent 43. If I, Q, percent 44, Y, percent 45. And so we see these references here updating as the thing that's referenced is changing. So how does this work for this particular example? Well, if we go here and I get this percent, and I get this as now as a live smart percent reference. Now if I go here, it's working as we want. And of course, if I go in and change one of the particular values here, this updates because we changed it. Go back to 4, that's changing, as you see that %52, it's changing as we do stuff. So we've now got this unnamed sort of variable that updates as the thing that it's referencing updates. Okay, so to look at this in more detail, I've cleared all the evaluations out of this particular section, and I'm just going to quit the kernel, and let's do this a little bit slower. Let's talk about this creating the smart percents again. So in other words, here, if I just type the % key, it comes up with this menu, and I could click on this, it gives me a % reference, or if I type this % key, of course, it comes up. If I cursor away from that menu, it's no longer there, plus W. I have to actually type that menu here and get that particular input here. Okay, and there is another way, of course. If I just go here and I hit escape, it'll turn that into the particular reference in escape, and we'll do the same sort of thing. Okay, so I've got this % reference. How do I use it? So let's just actually create some junk here, some stuff inside there, get that, and paste some cells. So I've moved the referenced cell here. This is this original %1 in and out pair. I've moved this off the screen. And so from this output, from this reference here, I can go to the linked input cell, and I could, of course, change it now or just reevaluate it. I'm going to change it, of course, and changing the thing that's referenced, the origin, will change this thing that's referencing that origin and cell, and now changed to %3. And of course, from here, I could go to the output cell. Okay, and so that's how you can navigate with them. Let's get rid of this so we can see them both together and follow this in a little bit more detail. From that output cell, that we're dealing here, we can go here and we could turn around and replace the output, replace the % reference with the output, replaces it with the output. We could replace it with the input, as we see, and note it is actually replacing with those boxes. It hasn't collapsed the 1 + 1 to be 2. It's replaced it with the actual input, and we could replace it with the iconized input. Of course, that works as you'd expect. Go back to here, the state, and then we could even turn around and replace it with the output iconized. Okay, but one of the other things we can do now is if we have something else that depends on this, we have a chain of these references. We're going to do 2 plus that result. Gives me a new result. I'm going to do f of that thing plus 1, and then finally % of that thing. And so now this %8, of course, references, you can evaluate it, it references this last thing, and of course, that if we're going to replace this by this rolled up inputs, well, that's going to change this %8 into this input, f of %7, the smart % reference, plus 1, %7 is going to be replaced by this input, 2 plus 6. That input is going to be, the 6 is going to be replaced by the r plus 3, and the 3 is going to be replaced by this 1 plus 1 plus e. And so if we do that, we actually roll up the inputs, we can actually see that whole chain actually being rolled up. Okay, so that's kind of grand. And one of the whole advantages of these smart %, of course, if we had replaced this n6 here with something like r plus %3, would get some, that works. It gives us some value, 2 plus e plus r. We'll even put it here, just there. So we can see how it should be. But if we now quit the kernel, and this is going to take us into a different state, and I'll talk about states in a second here, but this goes into this dormant state. These things are no longer sort of evaluated. If we evaluate all these cells here, if we evaluate this input cell, in fact, if we evaluate this cell here, it's going to say this dormant cell, it can't evaluate it right now because this reference here isn't evaluated. It references this front-end pair, but it doesn't exist in the kernel. And so we could reconstruct the input and evaluate that reconstructed input from the output cell. That doesn't reevaluate the input cell because this input cell is still not reevaluated. But if we reevaluate this input cell, this reference here will become hydrated as we describe it. And so then we get this particular result as it should be. And we see this reference here to this thing here is now hydrated. This one isn't, but if we evaluate this reference here, this one gets hydrated as well. Now it's interesting as well, of course, if we just quit all the kernel and then we just select all these things and evaluate them, this r plus %3, of course, was frozen in time. It didn't exist at this time. It wasn't evaluated. but of course these references were. These smart percents adjust to whatever these values were. So they're kind of powerful. Okay, so let's now go and talk about these states a little bit. Okay, so to talk about the state of the smart percentages, let's actually just click the kernel, run a new slide, and start off with our favorite example of 1 plus 1. And let's create a smart percent reference to that. And this is now working as it has on the previous slides. And so here we see this is a full reference. And now I'd actually like to say, what's the state of this reference? It has the in cell, the out cell, and the kernel reference going to it. And so let's actually take a look at that. If we show this expression, we see this is the underlying form. It's a template box here. Template box. It's got a %ref tag, which we'll talk about in a bit. And this is the link to this in cell here, right here. And this UUID is the link to this out cell. This is a cell object sort of link, and we'll talk about that in a second. But for this slide, I want to talk about this. This is the status of this % reference. And so through the magic of the front end, it sort of updates this. This is the very glorious shenanigans that the front end goes through to actually that I put in here to make this actually all smart percents to actually do the right thing. And so we can see it's got a link to the kernel, it's got a link to the in cell, and a link to the out cell. And so if we turn around and actually get rid of the kernel, in other words, break the kernel linkage, this now goes back to a dehydrated state. It's not hydrated, and we can actually see it no longer has this kernel linkage. The kernel linkage is not there. It says it's a no. We delete that out. It also has now, it no longer has the out linkage, and it no longer has the kernel linkage. It still has the in linkage. It can still do stuff right for now, but finally, if we turn around and we get rid of the in linkage, this now then goes to sort of a dead state. We could turn around and paste that state back, and it'll come back. But of course, if it's gone there and it really is out of the way, then it is really gone. Then evaluating that, it'll turn around and we're hosed. We can't do anything besides just replacing it and generating a new cell. Okay, so that's the linkages in this notebook. But what happens if we've got external notebooks? So let's actually go create a notebook here. And in fact, I would mention, of course, the updating of this in 1 plus 1, plus 2 here, plus 3, something else like that. We get these different references. Of course, all of these references, the linkages for these particular cells, the NUUIDs, are the same. They're linking to the same cell here, as we can actually sort of see, which is this one here. And so, of course, when we update this, all these linkages now get updated. Okay, and what happens, of course, that's multiple links, multiple % references or smart percents, and this notebook are linked to this pair. What happens if we put this in an external notebook? Well, it formats a little funny here. It's telling us that this here is linking to a cell in a different notebook. It still gives us the right message and everything. It still works, it evaluates, but of course, if we turn around and we close this notebook, this would be the same as deleting these particular cells. So if we go here and delete this particular cell, this pair, all of these cells look like they're still fine. The kernel value is fine. It still works for now, but as soon as we sort of save these notebooks, these are going to be dead. And so if we go back, and so that's the same way as if we turned around and saved this notebook and then closed it. And so let's move on and actually take a look at cell objects and how these linkages are maintained in the front end. Okay, so to talk about cell objects, let's create another notebook a little bit like we had before, and actually quit the kernel, as we've done, and then get our trusty example of 1 plus 1, and get a smart % reference to that example. Okay, and so that's linked, and as we can see, it has the kernel linkage, yes, in linkage, yes, and out linkage, yes. Okay, so how is that represented? And of course, we see that this is a link to this particular UUID. Well, it's that cell there. So let's actually take a look and get NB equals input notebook. Okay, and then once that's done, then we can actually turn around and get cells of NB. And so this gives the 4 cell objects. That's the first, that pair there is the in and out, and this one here is the in and out here. So this one will be the first cell, this one right here. And in fact, if we do, we go selection move of that, comma, all comma cell contents and take a look, we can actually move the notebook selection here to that particular input cell. Okay, and so how is that working? Well, if we take a look at the full form of that, we actually see, well, full form if you want, full form, you actually see that this linkage here is the same as this linkage here, right there. Those are, the second thing in the cell object is this sort of session ID. We won't talk about that too much, but you can sort of see this is the link to this NUUID. And in fact, this notebook, if we turn around and save it as on the desktop, links, and replace the current one, and we go there, and then we open this in BB Edit, and take a look at the same time, and go back here, look at there, we can actually see that all of these links are exactly the same. So when we actually go and get that 1+1 and we serialize it, we see it's a row box of 1+1, but it doesn't actually list this expression UUID, but we can see it in the file there. There's the UUID of that in cell, and we can actually see it's exactly the same across all of them here. And the same with the out expression here. This one thing here is the same as this right in the actual notebook, which is the same as this thing right here. So that's how they're all actually linked. It's using this internal linkage. And that means, of course, that if we got something like this and we paste that, and then we save it, and we take a look now at the UUID, we see this other expression down here has a different UUID. And in fact, to actually get this thing to link this particular cell, it's linked to the first cell. But if we wanted to, we could actually turn around and just be really nasty here and go there and grab the in cell here, paste it in there, and grab this. And now we've manually retargeted this particular percent reference to point to this in cell here. And if we evaluate that, then it's retargeted now to the second cell. So these UUIDs really dictate exactly where this thing is actually targeted. And it means, of course, when we copy and paste these particular cells, we're not duplicating the UUIDs. They're still existed here. So that's why this thing is targeted to the right thing. Okay. Okay, before moving on to template boxes, I'd like to talk about some alternative ways to create smart percents. And so the normal way of creating a smart percent is just we type a percent character, we get a completion menu, we choose the item off it, and we get a smart percent. Or we enter in %2 here, and we escape it, and that will also give us a smart percent. But there's another way, and that is output linking. Here is an option here under the option inspector, and we turn this on for the selected notebook. What we're going to do is disable the completion menu, but turn on evaluation. So the links are created on evaluation. So now if I type a 1+% and plus R, for instance, and I evaluate that percent will turn into a smart percent automatically and refer to the right thing, which is %3. And if I have some other percent, 4, for instance, plus G or something else like that, that will also turn into the right thing. And of course, something like percent plus W as well will turn into just the right thing. Okay, and there's another thing we could actually do. Instead of just on evaluation, we could do it on entry for the selected notebook here on entry. And so that means now if I delete some of these and type in 1+ %4, for instance, and now I type any other character that finishes the percent, like a plus, it automatically converts to a percent reference. And so evaluate that, and then I have 1+ %, plus E or something else like that. It'll automatically convert. Okay, so those are quite useful. And indeed, in the future, we might even think about changing the default now that that percent reference has been out for a bit and it's baked. And it's quite a useful feature that a lot of people are using. Okay, so let's just take a quick review of template boxes by looking at binomial and traditional form here. And so as we see, I can now go show expression, take a look at this output form, and we see this binomial is actually represented in boxes as a template box of A, B, and binomial. In fact, that tag tells it how this thing should be interpreted, and it tells it how it should be displayed, amongst other things. And if I change that tag, Legendre P, for instance, to a different function, this now behaves as a different function and it displays as a different function. How is this working? Well, let's go take a look. And if we go here and we take a look at the style sheet, and we're going to go to the main style sheet, go to the core style sheet, and then go here, and then find binomial, and we'll put this on our local style sheet there, and we'll find Legendre P function here, and put that on our style sheet. Okay, so this is our local copies, and so we want to get back to this. We'll just put a binomial. Yep, it's displaying as it should. How does this work? Well, what happens is this template box has two arguments, an A and a B here. And what it does is it takes a look at the option, the display function option. You can pass it directly to the template box, or more typically, of course, we always put it on the style sheet. So we can just change the styles, as you see, and all of the various interpretation, display, and all the other bits will just follow through. And so that allows us flexibility to change and change the style sheet and future versions and everything. It's not baked into the boxes in the actual notebook. And so here we see the display function is a row box of this particular thing. So it takes this first argument A here and it substitutes it into this argument here, the first one here, this grid box, and it takes that B here and it puts it into the second argument there. And so then, of course, it looks like exactly as if we had gone in here and got the A and put this in here, A and put this other, got this B here and put this in here, and B, and then put that in terms of raw boxes, and then it displays like that. So it's actually plugging these arguments into this display function to rise at a new set of boxes, which is how it should be displayed. So that's grand. So what it means, of course, is we can go here and we can actually change these boxes. Let's just do something silly, put a P there, for instance. And then we see that this binomial, of course, it's displayed with a P here instead of the closing bracket. And so by just changing the display function, we can change how these things are displayed, and indeed how they're interpreted by changing an interpretation function. Okay, in the same way, this thing was the Legendre P. If we go here and take a look at the Legendre P function, we go in here, get that template box, change its tag. Of course, that changes its behavior. And if we change the Legendre P function as T here, for instance, and you'll see that, of course, we're changing the function. Okay. Okay, so how is this related to the template boxes with a smart %? So if we take a look at this, we've got our links, our UUIDs and everything, and we've got the status, of course. And the status, as we go in and we change one of the, for instance, delete the in there, and we see that, of course, the in linkage is gone, and the status is changing. And so that's done by the sort of auto magic of I do it in the front end, or we do it, of how that works. But we get this different status. So let's actually go, let's get rid of those styles, and let's go and take a look at the % reference styles that we saw here. So go to the top here, find smart % here, and let's actually grab that %ref. It's one of the styles, and let's grab these other ones. And I'm about to explain exactly how these are involved with template dispatching. Okay, so we've grabbed these styles, and so we can see here, this template box has a style % reference. And so it has a display function. And what is this display function? Right in here, it's this thing right here. And so this is the template box display function. Let's go ahead and paste that. And let's take a look at that in terms of raw boxes. And let's plug in a few of the parameters, just like we did before. And so the ref is slot number. We see the slot number is 8. So let's just put that in there, 8 here. And the slot status, well, let's go in and just change the status here. And so we can see here, slot status, like that, and evaluate it. And it looks like %8. In fact, if we had gone in and we deleted the in cell like we did before, it would look like that, which is exactly what happens if we delete the in cell. In fact, now if we actually turned around and said we don't have a kernel as well, it would look like that. And if we have a kernel and we have an in and out, but no kernel, it looks like that. So what's actually happening right here in this display function for this template box is it's going in here, and this template tag of the inner box is now depending on the actual, the status here, the slot status that's being passed into the function. This didn't used to work before. It's a pretty small change actually, but it enables stuff that's really powerful. And so all of the styles here, right down here, determine how these styles actually look like. And for instance, we might want to actually take this particular style here and go in and change it a bit. We might want to, we'll grab that particular pane box, which is in there. You have to take a look at the boxes. We're going to actually wrap that with a row box. And we're actually going to give it the number that's in there as well. So we're going to put inside here, we're going to put in slot ref. And so we're going to go modify the style on our style sheet by putting that in right here. And this thing here will now change, and it'll give the actual number right now, slot 8. So we've added, by changing just the particular style for the no kernel yes, we've changed how that actually appears. And so it's the slot dispatch, this template dispatching mechanism that's working. Okay, so let's quickly look at template dispatching. So we've got two styles here. One, we can actually take a look on the style sheet here a little bit more. Take a look at the good style. We just see it's a frame box of with the background, and the bad style is just a background. Okay, so we've got those. So given those styles, we can have this other new style, new template box here, which is doing template dispatching. So I'm going to walk through this, but it starts off in the good style state, which is looking green. If we click on the button, it changes the state to bad style, does that through dynamic template boxes, but it displays that through template dispatching. So as I click the button, I flip from bad style to good style here, and then the bit the actual style displayed is through template dispatching. So let's quickly talk about dynamic template boxes here. So if we've got an argument here and we've got a slider box, a control with the dynamic value, slider box, the dynamic arg, we evaluate that, we move the control, and that will change the value of the arg in the template box. This is dynamic template boxes. Covered it before in previous talks. It's a powerful new feature. Not so long ago, and it allows really nice things. But so this is a similar example here, working with a toggler box of a dynamic state. And so here it's going from good style to bad style, and it displayed as good and bad. So on the good, we see that it's good style. We click on it, and we see bad is bad style. And so as we click on the toggler box, we change those states. And so this is how this outer style is working. If we take a look at that here, and we look at the style sheet, and we look at outer style, we see this first bit. This is the dynamic template box from before. And this second argument to the grid box, this thing right here, is actually a template box with this ref of the slot number here and the slot state. And so that state, this is the template dispatching. And so depending on the value of state, it goes and it uses a different style to style this actual template box, because it's the template arg, template tag. Right, and so that works. And so this is really kind of a powerful mechanism, because now, of course, if we want to just change bad style, for instance, we want to make it, italic and blow up its font size a little bit, it's now worked. And so as we've changed this, we just change the style, do something else, make it bold, do some of these other effects, we can get it to turn around and behave in a nice way, in a nice modular way, instead of having some big if statement inside the dynamic to allow to make sure that this affects the changes we want. Right. Okay. Okay, let's put this together and change some defaults. If we open our previous notebook here, this links, we see that, of course, we've got some of these cell labels, and it looks like, this is out 2 from a previous session. In fact, it's saved here, cell label out 2, but it looks like out blob. In the same way with this is, N2, but it's N blob, and this is N1, but it's N blob. So we can change that by taking a look at cell label for the selected notebook, and we see this. It was sometimes I kind of prefer actually showing the numbers. This is an internal discussion, but it was decided that we'd show these blobs. A number of people like blobs to actually really show that they were really expired. But if we don't really want to show they're quite so expired, we can actually change this right here, this expired styles right here, and actually get the numbers back. But of course, this is referring to out 1, but it doesn't actually have the number. But of course, we've just previously done this. We've gone here. If we take a look and go here, we've actually got the right style where we've added that. So we can just go to links, go here, take a look at its style sheet, the link style sheet, paste that in, and now we've got numbers. So we've got the numbers on the in and out, and we've got the numbers for our smart percents. And this is possibly a little bit more useful because smart percents make these numbers, kind of nice. And so if we put those together and we make a new style sheet and we put it under user base directory right here, this new default, and we go in here and we're actually going to go and change this default and call it default and take a look at it. We actually see it's got the notebook, it's got the style, the cell template label, and I've changed the other styles accordingly where we've gone in here and we've added this row box with the style in here. And now, of course, if that's the default, when we go, and I'll close that without saving the changes, and I'll take a look at links, and it'll have all these particular styles. And in fact, any new notebook will. If I go back here, change this, remove it to new default here, and then go back in here and then open this notebook again, we go back to unnumbered sort of styles. So it's a way of putting this in. It's a kind of a nice little way. We can just make a new style sheet. And of course, once we have that style sheet in there, all of the new notebooks that we have, not just links, we get a new notebook here, 1+1, whatever, and we take a look at its style sheet. It'll go to the default, and the default is here, this one, which is inside our user-based directory for me, and then inside there's the main normal default one, and so on. So that's a nice way you can actually change the configuration options. And for smart percents, it might make sort of some sense to actually do that, to have some labels for all the various bits. Okay, let's bring this all together. Okay, in conclusion, smart percents are a neat new feature that's incredibly useful in the front end. There's a lot of edge cases that I didn't go into here to do with, like, for instance, history length, the cell context for in the help browser, the tooltips on the iconize, the completion menus, some of the elision stuff, and many other features. So I also want to thank many of the people internal to Wolfram for the help in smart percents: Noah, Kevin, John, Lou, Ian, Chris, and many others. Thank you all. There's other front end talks today and tomorrow. Let's bring on the questions. Hi. So that was a bit quick tour de force. So there were some of the questions that were asked during the actual session. So I tried to answer them sort of live in the chat sessions. Then it'll be available actually in the chat. This talk, I have been told, will be available in about 72 hours. I would recommend, because I tried to actually structure it so the first bit of the talk was, pretty followable. And then you'd be able to sort of see it. And then for sort of the experts around there in TemplateBox, I sort of ramped up the speed a little bit towards the end. And so it showed some of the advanced applications that you can actually do there. So in the last 10 minutes, don't feel bad if it takes you, you've got to actually stop the video and take a look at everything. And of course, we're available here at Wolfram Research, any of us, or me in particular, to answer any questions about this new feature. Yeah, it's great. But I probably shouldn't take too much time unless there's any other questions live in the chat or in the Q&A. Great. Have a great conference, and I'll see you in the next sessions. Okay, thanks.